So I'm outside the ham shack wall here. This is with the box for all the cables. And one of the checks I wanted to make is using a mega ohm meter to see if there's any leakage. So a regular VOM or digital multimeter may max out at about 10 mega ohms. But using something like a Megger, this can go up to 1,000 mega ohms. I saw this on Ham Nation about a month or so ago. George, W5JDX, picked up one at a ham fest, and that night on Ham Nation I searched around on eBay and found this for like $44. So the way this works, it has to generate a much higher voltage in order to measure mega ohms of resistance. So the way that does that is that there's a hand crank generator in here. And as you crank that, the meter starts going up. I don't know if that'll show up here. Okay, it's slowly going back down. It's at like 20 mega ohms right now. If I crank it up into this open circuit, it goes up to 1,000 mega ohms. 1,000, danger, 1,000 mega ohms. It has a couple of binding terminals, so I made a mega to SO239 coax adapter so I can just screw a coax in. I found an article, I'll put it here, from a 1973 magazine on using a mega to check your coaxes. And I'm thinking off the top of my head, but I believe if anything above 200 mega ohms is fine. So I'm doing this now with a new installation. So if I see problems down the road in 5 years, I'm not hearing as well, or I got some weird SWR, I can repeat the measurement and see if I have a lot of leakage, maybe the coax has gotten wet in the conduit. So let me set this up and we'll mega a piece of coax. Okay, so I have my red coax connected to here, and it's disconnected at the base of the tower, so it's just the length that's in the conduit. This has to work into an open circuit. If you feed it into an antenna with a ballon, it's not going to work. So I can crank this up. You can see the meter go up, but it's basically all the way up here at the top, 1,000, 500, 200, so it's decaying down. But that's fine. So that's how you mega a piece of coax. Now I just need to write these numbers down. Hi, Randy, K7AGE. It's about the third week in April. I'm still working on the project here. It will be done. So what I've been kind of doing since the last video off of camera is that one of the big things was to figure out the rotor loop. And with the Yaesu rotor, it actually rotates 405 degrees, so that's 1 1/4 times around. So you have to make sure there's enough loop. Now if you had a guy up on the top of the tower, he could look at the coax, give it some slack, tape it off, let the guy on the ground rotate it. The guy on the top can see what's going on and say, oh, nope, wait, we got to adjust it. Well, I can't do that with this because I'm not climbing to the top. And a lot of what I've read on the internet says set your antenna for the midway, say for 180 degrees. In my case, it'd be 180 plus 45, and set your loop for that, and then you'll have enough to go either way. Well, I can't have the beam at that angle and have it anywhere where I can get to it. So, a lot of trial and error. I ran just a scrap piece of coax up to the top of the tower, and I tried various different scenarios. So I would try a loop, and I mounted my GoPro camera on the beam here so I could watch what was going on. So I'd set up the coax loop, run the tower up, spin it around, run the tower down, take the memory chip out, go put it in the computer, go look at it, go, no, got a problem. Too much slack. So go back out, lower the tower, or the tower's down at that point, change the coax, reset the camera, run it back up, rotate it around, drop the tower down, wash, rinse, and repeat. So I think I went through that at least 6 times. One of the problems I was having is that on the thrust bearing, there's 8 bolts sticking out. And the last thing I wanted to have happen was the coax to get caught. In one trial, the coax actually got caught in the bolt and started bending it the other direction. No good. So I kind of gave up. I found a plastic soap bucket that laundry soap comes in, about 1 foot in diameter, and I cut it down to about 5 inches, and I cut a little bit larger than 2-inch section in the middle where I made a bunch of pie cuts so I could bend those out, and made a cut all the way down the edge, out from the center and down the edge of the bucket, because I wasn't going to take the beam off to slide the bucket down. No, that's not going to happen. So I was able to pry the bucket and get it on there, and then all those little tabs in the center were sticking up. I put a stainless steel hose clamp around there, and now there's really nothing there for it to get caught. One of the other things I've done is I have one piece of coax going up to the Navassa 5 beam, and I just ran a bunch of SWR checks. In the information that's on the web are the plots from the antenna modeling software. Well, the SWR is a little bit higher than those plots. Now, in just about anywhere you'd want to operate, except for maybe on the way on the top of the band edge on 10 meters, that's 1.6 megs wide. You're not going to get an antenna to cover all of that. So I've wrapped the coax cables going into the balun. I have an initial few wraps of this 3M term flex. This is rubber splicing tape. This is self-annealing tape. So what it does is that you wrap it around and it sticks to itself. It's not sticky, it's a chemical reaction. So on the roll, it actually has a backing here that you have to peel back. You have to peel this back. Then on top of that, to give this UV protection, I've used the Scotch 3M Super 33 Plus electrical tape. When you're working with these tapes and things, you don't want to just pull it and have it snap. You want to cut it because you don't want it to relax and pull back on itself. So both of these were things I bought from DX Engineering. And one of the other things that I've done is use 2 1.5-inch electrical sweeps. So I have one mounted on the boom so the coax can go through, so there's a nice gentle bend there. And I have another one on the tower, I'll show you here in a second, that comes up from the other side. This was an idea that Barry, K7GVB, used on Bob's and 2 OML's tower in Phoenix with his Step IR. Both of these guys you've seen on my videos from Quartz Fest. So I think it'll work out. Just use some stainless steel hose clamps to clamp it onto the metalwork. Okay, the next thing I'm going to work on is prepare a cable with a connector that's going to go up the tower to the diamond VHF, UHF omnidirectional vertical at the very top. And I use color electrical tape to take and identify my cables. And I've already seen some of this stuff kind of starting to unwrap. So I've got some clear heat shrink table with adhesive on the inside that I can put over this and it will never come off. I'm going to peel off about 6 inches, wrap it about 6 inches down from the end. It's kind of hard to see the camera out here in the sun, so hopefully you're going to be able to see all this. I can slide this down over that. Drill Master, Harbor Freight heat gun. Get this stuff out of the way. So next I need to strip the cable. So I have the DX Engineering cable grabber tool. And put that on there. And I have the stripper. And if you remember from back in my video number, I showed using all these tools to make a bunch of cables, so I'm not going to go through that all extensively again, but basically the cable slides in here up against that stop, and you clamp it down, and you wind it round and round, and you'll feel the resistance kind of ease up and go for a few more. And a hint from my friend Barry said don't pull off because that puts a lot of stress on the blades. So I can open that up. Now I can peel these off. So there's the one to the center. I forgot a step. I can use the other end of the tool, which has a slicer. So I'll put it in there to the coax is at the end, grip down, and pull. And that now cuts lengthwise down the cable. And you can see I didn't go around enough because I still have a lot of the braid here. So the braid and the foil shield need to be removed from what's shown here. There's another cut here about 1/4 inch down, which I'll take off here when I get this cleaned up. So in the toolkit is these nice little sort of wire trimmers. So I'm just going to go around here and snip all this stuff off. Take a knife and I just kind of score the foil here a little bit. Don't want to go deep. It's pretty thin. And now I should be able to peel this off. There it goes. And of course, I'm trying to do this on camera. It wants to be just a touch difficult, but you kind of work at it and get that off. There we go. Now, the last thing is to get this last piece off here. There we go. That comes off. There we go. We got all that off. Time for the connector. So we have the ferrule, which you want to make sure you slide down the coax. And the connector, these come in a bag. And I kind of like to take the barrel off because I want to make sure the ferrule is positioned up to the back of the connector here. So slide this down, make sure you have it going in the right direction so it can thread back on. Now you slide this down and goes underneath the braid, and the foil is underneath there. And you slide the ferrule up. You want it right at the base of the connector. You want nothing to move. The ferrule is up against the edge of the connector, and you don't want to move that. So you put this on here. Make sure it's tight. Because I'm trying to look at the camera, and oops. There we go. And let's go. And there we go. It's tight up against there. That's on. Next thing to do is to solder the center conductor. And one of the changes I made since the last time, I bought this 100-watt Weller soldering iron with a big tip. This makes this a lot easier. So I don't have a sponge, but I have a wet rag here, so I'm just going to wipe that off. Got my solder. Put that on there against the side. Sometimes just a little dab on the outside here will help the conductivity of the heat. So I really want to see it melt on the copper too. Okay, it's melting on the pin. There, it's just starting to melt on the actual copper. I want to make sure everything is hot. I don't want a cold joint, a joint where the solder hasn't flowed. You don't want to put too much, you don't want it running down the outside. Here it's boiling, flux is boiling, there we go, now it's good and hot. That's good. And while we have the connector on the whole spool of coax, we can hook up the Megger and crank it up. And it goes up to 1,000 megs. Okay, so I've got the cable and the connector made up, ready to feed it up the inside of the tower. Everything's going to go up the inside. And what I've decided on is that all the coaxes that go up into the mast that rotate will go up the inside here on the far leg, because that's where the sweep comes out at the top. The other coaxes for dipoles, I'm going to bring them up this close tower leg, and the rotor cable and a cable that's going to control a relay to change the polarity of my 2-meter beam between horizontal and vertical. I'll run those up the top leg there. So I got the spool in the back of the gator here, so I'll just feed it up through here for the time being. And I just kind of work my way up the tower. Okay, I can push it through the sweep here. Here it comes out. Now this is the path that the second cable needs to take. So it needs to go over. And I'm just going to wrap this around. Again, it's going to take the path of this one. So it's going to come up, go through the top sweep, and come out here right at the boom mast clamp. It's just about right. So the connector is right here in the bottom. So I need to get my deep sockets and take this apart. So this is a 1.5-inch aluminum piece of tubing I got from DX Engineering, and it fits snugly inside this 2-inch tubing with 1/4-inch walls. I just put a bolt here. So it's got 2 little bolts here. Okay, that comes right off. Let me get the cable up here, put it on, tape and seal it up. So I have enough slack so the antenna can stand on its end here. So I've attached the coax. When you put on a PL259, there's 2 little like teeth that stick out. And on the SO239, there's about 8 little notches. So you want to make sure when you are putting the cable on, you twist that and you feel it grab. Those teeth goes down in those notches, and then it's properly seated. Then hand tighten it, but then just get it a little snug with a pair of pliers. You don't want to overdo it. You don't want to loosen up something inside or break something, but you just want to give that a little snug. So I have this term flex, I believe it is. So I'm going to peel off, I don't know, about 8 inches or so. Cut it with a pair of scissors. You peel off the backing. And then you wrap this around itself, down over the connector body, and down onto the cable. And I need some more. Continue this around. And down onto the cable. Of course, this is all inside here. I'll start that down here on the cable. Wrap that around, overlap it by about half the width of the cable or the tape, and try and keep it flat. Together. And again, cut the tape. There we go. That should do. Okay, I have the antenna bolted back on, and I've got some 2-inch wide electrical tape. I'm going to use that to tape the coax here to the mast. So, get started here a little bit. And how low is it working? And the tower, you always tilt down, and we're good. So middle, I'd say 3 times around, 2, and 3. Scissors. Cut it off. See how that's not working way down until we get to the root area. Okay, so I have it taped up coming down the mast. So what I'm going to do now is make sure that these two are about the same. I'm not going to tape these up together for now. I can't run the rotor from inside the house yet, so we'll do that another day. I need to extend the rotor cable. So I'm just going to work on taping up the coax going down the tower, and then put the other connector back on, or put the second connector on. And that looks okay. So I think that's about all for now. Time to connect the blue from the tower to the blue to the shack, so I can use it for the 2-meter net tonight. And close the box up, close the other box up, pick up the tools, run the tower back up, and I think call it a day. So probably the next thing to do is to deal with the rotor cable. Right now it's just temporarily plugged into the rotor and running down here, so I can run it from here at the base of the tower, which has been really handy. I'll miss not being able to do that from out here. But I need to dress it down the tower, bring it into the box here, and cut it. I'm going to crimp on spade lugs, and it's going to go onto a terminal strip, or maybe the lightning arrestor terminal strip. I'm still toying where I'm going to put the lightning arresters. Probably one regret: the box where your cables are in, whatever size you think you need, double it. It's really tight in there. So I think that's all for now. Let me clean up, pack up. It's going to be dinner soon. Randy, K7AGE. Thanks.